So our definition of work, if we look specifically at motion in the x direction, so let's say we've got our block over here, there's our force, it's being displaced in the x direction. We said that the only component of this force that's really being utilized is its x component, and we said the work done is equals to the magnitude of the x component times the magnitude of the displacement. So that's how we're going to define this thing called work in terms of equations and numbers. So larger force means more work, larger displacement, more work. But we know this is the x component of this force. So we know Fx is just equals to the magnitude of this force times the cosine of theta, where theta will be this angle. So we can also just write this as the magnitude of the applied force, F in this case, times delta x times the cosine of theta. And that's where that expression in the slides come from. And this tells us exactly what we've been discussing so far. For example, if we've got a force that is being applied in this direction, right, and it's not enough to lift this object off this surface, then we said, well, if this object was stationary and this force is not enough to lift it off the surface, nothing's going to happen to this object. Or if I were to turn this force around and push down on the object, again, nothing's going to happen. I'm not going to be able to move this object. I'm not going to be able to push it through the surface. So in both these cases, even if the object was moving, so even if the object is displaced, first of all, that displacement is not due to this force, because this force is perpendicular to that direction. There's no way this force can cause acceleration in that direction. No way that this force can cause acceleration in that direction. So this force does no work because it's perpendicular to the direction of motion. Same thing here. This force does no work as long as this block stays on the surface. So if the force is not large enough to actually lift it up. And why? Because the force is perpendicular to the displacement. And this statement tells us that if the angle between the force and this direction of displacement is 90 degrees, the cosine of 90 degrees is 0. So the work done would be 0. So that makes sense. If we were to apply this force purely in the x direction, so we minimize its y component and maximize its x component, we get the maximal x acceleration, which means we get the maximal change in velocity for a certain displacement, which means we get the maximum amount of work done. So if that angle theta is 0, the cosine of 0 is just 1. That's the largest value a cosine can have, so that's the largest value that work will have. So if theta equals 90 degrees, it means no work. If theta is equals to 0 degrees, it means maximum work.